Okay, this problem says two blocks are connected by a massless rope as shown below. So the rope has negligible mass, and so does the pulley, which is not stated, but that's the assumption under which we're solving this problem. The mass of the block on the table, this is 4 kg, and the hanging mass is 1 kg. The table and the pulley are frictionless. Find the acceleration of the system, find the tension in the ropes, find the speed with which the hanging mass hits the floor if it starts from rest and is located 1 meter from the floor. All right, let's find the acceleration of the system. So here's the mass 1, and here are the forces acting on it. This is sitting on the table. There's the tension. The normal force is canceling the weight, so there's no force in this direction. The only force acting in this direction is the tension. There's no friction. So the acceleration of mass m1, the equation is T. So for mass m1, T equal to m1a. All right, so, and the equation for m2, here's m2g is the weight, and those are the forces acting on it. And by the way, in this diagram, A2 equal to A1. The magnitude of A2 equal to A1, which is equal to A, is what we are calling. They will give a different notation because the direction of A1 is different than A2, but their magnitudes are the same. Okay, and so the equation for particle 2 is m2g minus tension equal to m2a. We'll call this equation 1, equation 2. Now if you add the two equations 1 and 2, the tensions will cancel. Okay, so if you add 1 and 2, what you get is m2g is equal to m1a plus m2a. Okay, so the acceleration of the system is m2 divided by m1 plus m2 times g. Okay, all right, so let's add a page and then we'll calculate that. So the acceleration is, again, like I said, m2 divided by m1 plus m2 g, and let's put in those values. 1 kg divided by 4 plus 1 kg times 9.8 meters per second squared. Okay, so 1/5 of g. (1.96 meters per second squared). So that's the magnitude of the acceleration of the two objects. Okay, part B, find the tension in the rope. So find the tension in the rope, we can use one of these equations to calculate the tension. The m1 is 4 kg. So part B, tension is m1a and this is equal to 7.8 newtons. Okay, and then part C says find the speed with which the hanging mass hits the floor if it starts from rest and is initially located 1 meter above the floor. Okay, so part C, here is this object. It's traveling 1 meter in this direction, and its acceleration is 1.96 meters per second squared. So what is it that we're finding? Find the speed with which. So the speed will be, okay, we can use this equation. Final speed square is equal to initial speed square plus 2a times the distance traveled. Okay, so initial speed is 0, v square is 2 times 1.96 times 1 meter. Meter square is second square. So the speed with which it hits the ground is 1.98 meters per second. Okay, that finishes this problem.